So what did we talk about last Monday? Area of a triangle. So if I told you that I want to see angle A for this area of this triangle, you would tell me 1/2 BC sine A. If I told you that I want to see angle B for the area of this triangle, then you would tell me 1/2 AC sine B. And if I told you that I want to see angle C for the area of this triangle, you would tell me 1/2, what did I say? Sine C. So 1/2 AB sine C. All three of those will give me the same area of that same triangle. Do you guys agree? Okay, so now look what we're gonna do. We can't let cosine have all the fun with the law of cosines. So we're gonna do something with sines, and we're gonna call it the law of sines. So I'm gonna check this out. I have a half on each one, so I can multiply by 2 or divide by half. So those halves, they leave. Do you guys see that? If I multiply everything by 2 or divide everything by half. So I know this is no longer called the area formula because now I'm doing stuff to it. So I'm just saying that would have given you the area. Now that I've canceled out the halves, they're no longer it's no longer an area. And I'm going to divide all three of those. So let me rewrite it. So I have this. BC sine A is equivalent to AC sine B is equivalent to AB sine C. That is a true statement. Now I'm going to go ahead and divide by ABC. ABC. C's easy as 1, 2, 3. Where did I get that from? Is that a commercial? Oh, it's a song. Oh, my bad. But I think it was a commercial too, though. B's cancel out. A and C cancel out here. And A and B cancel out on this. See? Look what's happening. And look how beautiful this is. Sine big A over little a equals sine big B over little b equals sine big C over little c. We're going to call that, take a guess. What do you think we're going to call that? Yeah, law of sines. Good job. Now, I know before you guys go Googling stuff, you're going to go Google law of sines and you're going to come up to a web page and it's going to say this. A over sine A equals B over sine B equals C over sine C. And you're going to say, chop. But Google's telling me this is the law of sines. Guys, it's the same thing. Notice all they did, it's equivalent. They're all equivalent. It doesn't matter which one you call. They're both the law of sines. I don't remember which one Delta has. Delta might have this one. I prefer this one because that's the one I learned, but it doesn't matter. They're both the same. Cool or not cool? Cool. Now here's how you use it. It's really simple. So go to example 1. Now I know, look, it says angle, angle, side. Don't call it, yeah, okay. It's angle, angle, side. It doesn't matter if it's angle, angle, side or side, angle, side. It really doesn't. Okay, let's go ahead. Here's what I'm talking about. Not to scale. Draw a triangle ABC. A, B. Actually, let me put the B down here because I like the base to be in the bottom. B, A, B, C. So here's little b, here's little a, here's little c. So check it out. It tells me that little a, or actually it tells me angle B is 64 degrees, so I put 64. And it tells me angle C is 38 degrees, so I put 38. So, and it says little b is 9 feet, so I'm going to put 9 feet. And it wants me to figure out side A and side C. Okay, before I even start, see, this is why it doesn't really matter that. I know that all three angles in a triangle must add up to how many degrees? 180. So go 64 plus 38 in your calculator. And I know you guys can probably do this in your head. What's that, 102? Yeah. And then subtract that from 180. 180 minus 102. And 78 degrees. So that sounds like a boy band. We're 78 degrees. Tearing up my heart when I'm... That's 78 degrees? That's 98 degrees? Okay, I'm going to stop talking. Let's just do math. All right, here we go. I'm gonna make sure to edit that part out of the video when I upload. Okay, I don't know if you guys heard, but I was singing NSYNC, or was it 98 degrees? One of the two. They all sound the same to me. Okay, here's how you use it. I would use the 64 degrees and the 9 because those are perfect. Like there's an integer, and that's a perfect integer as well. So you go like this: sine 64 degrees over the 64 degrees creates the 9 equals, and then which one do I want to find first? I'm going to find the C first. Sine 38 degrees over little c. I'm trying to find little c. Now you're done. Just do what you've always done when you were in 5th grade or 6th grade. Cross, multiply, divide. So when I cross multiply, here's what I get. C sine 64 degrees equals 9 sine 38 degrees. How do I get the little c by itself? Because this is c times sine 64. Are you guys following along? How do I get c by itself? Yeah, divide. Divide by sine 64. I know sometimes I write too fast and you guys need to catch up. I know that sometimes we don't have fries for the ketchup. I'll stop talking because I'm just making it worse. 9 sine 38 degrees over sine 64 degrees. When you take the UH quiz, that's probably the answer that's going to be in there. But we're not taking UH quiz right now. We're doing delta. They're going to want a number. So you take your calculator, and I'm going to use the alpha feature. Alpha y equals enter. And then I'm just going to type in 9 sine 38 on the top and sine 64 on the bottom. 9 sine 38 divided by, what is it, sine 64? And because I want to try something out, look, push enter. I get 6.16. I'm going to store this to little c. Why? It doesn't have little letters. It just has capitals. So answer little c. Check this out, guys. This is so awesome. I'm going to solve, so now I'm going to do this one. I'm going to get A. I'm going to change my colors. I don't know, you know, that's a demerit. And I'm going to use a different color to get letter A. So check this out. I can do the same thing. I'm going to use this one again because I want it to be a perfect. So I'm going to write sine 64 degrees over 9 equals, and I'm going to write sine 78 degrees over little a. Now let's see if we can do this in one step. Little a is equal to, let's see, 9 sine, bless you, 78 degrees divided by sine 64 degrees. Do you see how I did it? And let's see what that is. 9 sine 78 divided by sine 64. So I'm going to put 9 sine 78 divided by sine 64. Bless you, squared, bless you, cubed. Bless you to the third power, fourth power. All right, so I have 9.794 or 9.795. Look how awesome this is. Watch. 9.795. And I need units, feet. Is there another way to have gotten this answer? Say yes. Yes. I could have done, if I wanted to, I could have done law of cosines, like what we did last week. Do you guys remember that? So look, I want A, so the 78 degrees, don't write this down, just listen. In a little bit, I'll let you write it down. You could have done this. A equals the square root. So let's see, I'm doing the sine 78, so I'm going to say 9 squared plus, what was C? Did I not put it in here? What was C, guys? Oh, there it is. No, I didn't write it down. 6.165. And I can't believe I didn't write it down. 6.165. Now, I stored it in my calculator as C. So I'm going to put C squared. Little c squared minus 2 times 9 times little c cosine of 78 degrees. And I bet you that's going to give me the same answer. 9.795. It is going to be digit per digit. Look how awesome this is. Look, I stored it into C. See how I already stored it into C? 6.16. Second square root. Look how awesome this is. 9 squared plus alpha c squared minus 2 times 9 times c times cosine 78. And check it out. It's going to be the same digit per digit. Wow. I think that's just amazing. How you can do two different things and still get the same answer 2 different ways. You don't think that's cool, guys? Okay. I think it's cool. But hopefully your SAT and ACT scores are growing exponentially. And your aptitude tests are hopefully growing as well. When you get to university, your math placement exams. And here we go. Now we're just using the formula. The next one says given angle, side, angle. It doesn't matter as long as they give you 2 angles on a side, whether it's angle, angle, side, or angle, side, angle, guys. So not to scale. And I'm going to draw another triangle. and I'm gonna call this A, B. I want the B. It's fine. It's fine. It's fine. A, B, and C. I didn't draw anything horizontal like on the base here. So little a is 8, so this is 8. Angle B is 64 degrees, so 64. And angle C is 38 degrees. I was not creative when I was creating this example. I used the same angles that I did last time. So because that's 64 and that's 38, the other angle is, what is it? 78. Yeah, I know. I must have been tired when I was writing these notes out. I usually like to make them different. Oh well. Here we go. Because they gave us 8, that's what I'm going to start off with. So angle A creates little a. So I'm going to write sine 78 degrees. That's the one we have to find. Over 8 equals, and they want us to find B and C. So here's little b and here's little c. So let's find B first. Sine 38 degrees over little b. Does everyone know how I'm putting those numbers together? Angle A over little a, angle B over little b. Yes, ma'am. Oh, yes, you're right. See, I was testing you guys. No, I'm going to leave it in there. And they can decide whether I was testing you or not. I make mistakes all the time, but that one was not. That one I did on purpose. All right, here we go. So I'm going to find letter B. Little b is equal to 8 sine 64 degrees divided by sine 78. Hopefully everyone saw that. Do we see how we do it in one step, or do you want me to show the 2 steps? Yeah, 2 steps. Yeah, we're in Texas here. Let's do the 2 step. Was that lame? Yeah, that was lame. B sine 78 equals 8 sine 64. Sorry, guys. All right. To get the B by itself, divide by sine 78. So B equals 8 sine 64 over sine 78. See? So hopefully you guys can see that. Take your calculator, do 8 sine 64 divided by sine 78. So I'm going to clear this. 8 sine 64, close, divided by sine 78. Did you guys get 7.351? Or no? Okay. Excuse me. B equals 7.351. All right, now I want the A. Or the A, I already got the A. I want the C. So I'm going to use again, what am I going to use again? I'm going to use sine 78 again. Sine 78, because I don't want to deal with decimals. I want to get the exact. Sine 78 over 8 equals, I said that I wanted the C, so I'm going to write sine 38 over little c. Do you see how we did that, guys? So from there, I'm going to put an arrow. I'm just going to say C is equal to 8 sine 38 divided by sine 78. Notice that I'm putting degrees wherever it's a degree. If you do not put the little degree symbol, it is a radian. So please put a degree. 8 sine 38 divided by sine 78. So let's type that in. 8 sine 38 divided by sine 78. 5.035. Is that what you got? And I need units. Meters. All right. Cool or not cool? All right, let's look at this one, guys. What did I just hear? Slobber. Sorry. Draw a triangle ABC with side BC as the base. Okay, here's my base, BC. The measure of angle A, so I guess that has to be A up here, is 60 degrees. So this is 60 degrees. If perpendicular is drawn from B to side AC, okay, here's my perpendicular. So that means this is also going to be my height. There's my perpendicular right there. And the height is 8 centimeters. So this black line that you see is 8 centimeters. What is the length of side AB? Okay. I'm going to do it with law of sines, but I'm going to show you could do this. This is a very popular ACT question. You could have done this without a calculator using 36 and 90 triangle properties, which is probably what you would do if you were taking this in the SAT. But let's do it first with law of sines. So, oh, you know what? We can do this without a calculator, the whole thing, the whole shebang. So watch. I know that this is, do you see this triangle in red? No? All right. They want to know what is this length. I'm going to call it x. So using law of sines, I can do this. I can go sine of 60 over, I know that this height here is 8. So 60 creates that 8 equals, and I know that this is 90 degrees right here in that corner, sine of 90 degrees over x. That's probably what you would do if you were taking the SAT. I'll show you a different way in a little bit. So I'm going to cross multiply and divide. So here we go. So x sine 60 equals 8 sine 90. And the only way to get x by itself is to divide by, yep. So x equals 8 sine 90 degrees over sine 60 degrees. All right. With no calculator, let's see. 8 times sine of 90 degrees is 1 over, what is sine of 60 degrees? Square root of 3 over 2. Good job. Keep, change, flip. 8 times 2 over square root of 3. That turns to 16 over square root of 3, which I would accept. UH probably does not have the answer written that way. So multiply this sucker by square root of 3 over square root of 3, and you get 16 square root of 3 over 3. Now, do you want to see this done a different way? Look, yeah, this is awesome. I'm going to do it burnt orange for those that want to go to UT. All right. If you would have realized this is a 30, 60, 90 triangle, and when you were in geometry, or maybe this class, I don't know, you remembered that the properties is n square root of 3, and 2n. Do you remember that from your geometry days? So I know that the hypotenuse is my long leg, so I would have put 8 square root of 3 right here. Oh, 8 square root of 3. 8, just 8. It's just 8. I want to figure out my, let's see, that AB is my hypotenuse, so I want to figure out 2n. So I'm going to write n square root of 3 equals 8. So I'm going to divide by square root of 3, divide by square root of 3. So n is equal to 8 over square root of 3. But I don't want n, I want 2n. So I just double it. So 2n equals 8 times 2, 16 over square root of 3. OMG, same answer. Now all I got to do is just rationalize it, right? Or radicalize it. So 16 square root of 3 over 3. Look at that. Same answer, different method. It doesn't, this is the beauty about math, guys. It doesn't matter how you do it. You're going to get the same answer if you know what you're looking for. By the way, are you ever going to use these tools? If you're an engineer, yeah, you're going to use them. But in life, like necessarily doing trig identities, like maybe you'll never do a trig identity in your adult life. It's not about that, guys. It's about knowing how to solve the problem. So you have problems all the time, maybe not math. When you get a problem, how are you going to solve it? What do you need to do? That's what it's about. So the more experience you have with this, the more experience that you'll have to be able to tackle the problems in your life. So, heck yeah, math life. Okay. All right. Look at this one. Look, there's a perfect example. Find the area of a regular hexagon. Sorry. Inscribed in a circle of radius 4 centimeters. How many sides does a hexagon have? 6. Here you go. I'm going to try to draw a regular hexagon. I'm going to try. Bam, 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 bam. Maybe I don't have to do the sound effects. Sorry. There it is. All right. You guys ready? Look at this. The radius is 4 centimeters. So from here, I'm just going to go, that's 4, that's 4. Come on, Morales, focus, miss. So I want to figure out this area. How do I do it? I know, look how many triangles I have. I know that I have 6 of them. And I know that if I do this, if I do one revolution, I know that one revolution is 360 degrees. So 360 divided by 6 is going to give me 60. So I know that this angle right here that I'm doing in red is 60 degrees. And didn't we just learn a little while ago how to find the area of one triangle if we have this angle and the other two sides? Yeah, we just did a little while ago. Area of that triangle is 1/2, just that one triangle, 4 times 4, sine or cosine? Do you remember? AB, we're doing law of sine, so it's going to have to be a sine of 60 degrees. Guys, area of a triangle, guys. You guys were looking at me like you've never seen it before. We just used it to derive the law of sines. Okay. Oh, sorry. Oh, no, we're good. So there it is. So check it out. Half of 4 is 2. 2 times 4 is 8. So 8, and then sine of 60 is? Perfect. Square root of 3 over 2. 2 goes into 8 how many times? 4. So 4 square root of 3. That's the answer for one triangle. How many triangles do I have? So multiply this, by 6. Multiply that by 6. What's 6 times 4? 24 square root of 3. That's the type of question the SAT is. An acute triangle, ABC. So let me draw an acute triangle. Let me make that B because I like the base to be in the bottom. ABC. And the measure of angle A is 2x. Okay, 2x. The length of AB is 4. So AB is 4. And the length of AC is square root of 3. AC is square root of 3. If sine x equals 1/5, okay, we'll note that. What is the area of the triangle? You need to use a double angle formula. Okay. Area of this triangle, we just learned it not that long ago. 1/2 this side times this side. So 4 times square root of 3. And then sine of 2x. And do they tell me the area? No, they want me to find the area. Okay. I know that sine x is 1/5. I'm going to have to replace the sine 2x with something. Do you remember what sine 2x is? We just covered double angles maybe 3 weeks ago. A month ago. Oh, man. No one remembers sine 2x. And I'm your teacher, so that means I'm bad. No one remembers sine 2x. You're close. It does have a 2. All right, let's derive it. Sine x plus x. That is 2x, right? That's sine x cosine x plus cosine x sine x. How many of these sine x cosine x do I have? So this is 2 sine x cosine x. I was your teacher, guys, so you guys are a reflection of me, so here we go. All right. So I'm going to replace the sine 2x with this, 2 sine x cosine x. 2 sine x cosine x. All right, there it is, guys. We got everything. We have sine x. We don't have cosine x, but we can get it. How are we going to get it? From this guy. That's property of a right triangle. Notice that's a little darker red. So here's my right triangle. Here's my angle x. And sine x was 1/5. That's a 1. That's a 5. What is 5 squared? Minus 1. So this is the square root of 24, which breaks down. 6 times 4 is 24, right? What's the square root of 4? So square root of 24 is the same thing as 2 square root of 6. I got everything. So, oh, where'd 1 come from? Say it again. Okay. Here it is. I got everything. Oh, I'll wait. I'm waiting. Yeah, I got that from the sine x, 1/5. One half times 4 times square root of 3 times 2 times sine x is, what was sine x? They told it to me. 1/5 times, what is cosine x? Adjacent over hypotenuse, 2 square root of 6 over 5. All right, let's see if we can do this without a calculator, guys. Let's see. Don't worry, I'm going to go slow. I see a half and I see a 2. out. Do you guys see what I did there? All right. The only denominators I see, this is all like over 1, right? I see a 5 times 5, so I know that my denominator is going to be 25. Let's see what I see. I see 4 times 2. I'm doing the outside. What's 4 times 2? 8. And I see square root of 3 times square root of 6. So 3 times 6 is 18. Okay, this breaks down. So we're so close to the answer. 18 breaks down 9 times 2. What's the square root of 9? 3. And what's 3 times 8? There it is. So my final answer is 24 square root of 2 over 25. And let me put that in red so no one confuses it. That's my final answer. 24 square root of 2 over 25. How do we feel, guys? All right. And last one. Okay, this question is going to come out a lot. All right, let's talk about it. If the area of triangle ABC is 14 square meters, with A equals 15 and B equals 8, find all possible measures for angle C, round answers to the nearest hundreds. Okay. The triangle can either be acute or obtuse. I guess it could also be a right, but if you get a 90 degrees, then it's just one. It's either acute or obtuse. You will never have more than 2 answers. So if you see answer choices 3, 4, and 5, those are the dumbest answers, scratch them out. You can never have more than 2. Are we clear? All right, so here we go. I'm going to draw a random triangle, A, B, C. Little a is 15, so put it in the right location. Little b is 8, put that in the right location. They want all possible angles for angle C. Perfect, they gave me everything I need. The area is 14, so I'm going to write 14 equals 1/2 times 8 times 15 sine. I'm going to put theta because I prefer to write a theta instead of a letter. Sine theta. So here we go. What's half of 8? 4. And what's 4 times 15? 60. So now when I'm trying to get sine theta by itself, so I'm going to divide by 60. So sine theta equals 14 over 60, which I know reduces. 2 goes into 14 7 times, and 2 goes into 60 30 times. I don't think it reduces more than that. Are we okay? How do I get the theta by itself? Arc sine 7 over 30, and I'm going to get my answer. So I take my calculator. Second arc sine 7 over 30. I don't have another angle. So 13.5 degrees. Did they say nearest tenths or nearest hundreds? Nearest hundreds, so never mind. 13 point, oh yeah, 49. 13.49. But I'm going to use them all though, because I want to show you guys something. So I'm going to just store that to A. Store alpha A. All right, what if I want another angle? If they give you another angle, add them up to make sure it's not over 180. If they want another angle, do what? Subtract it from 180, that answer. 180 minus alpha A. So my other answer is 166.51. So there it is. So theta 1, and I'm going to write theta 2 equals 180 minus 13.49. And that gives me, I already forgot, what did I say? 166.51. And I know what you're thinking. Maybe you're thinking, Chop, those won't give us the area of a triangle with an area of a triangle 14. Yes, it does. Look at this. I'm going to store this to B. Store alpha B. And look what I'm going to do. I'm going to see if I get that 14. So 0.5, what was it? Times 8 times 15. And look, I stored it in A and B, guys. So I'm going to do A first. Alpha A. Oh, alpha A with nothing in there. Sine alpha A. Look at this. Push enter. Do I get 14? Now let's do it again. I'm just going to scroll up. And instead of A, I'm going to put what letter? B, because that's the other letter I used. And let's see if I get 14 again. Look at that. One's an acute triangle. The other one's obtuse. Cool or not cool? All right, guys, that's it. You're set free. So you just got a delta. We are going to have a UH quiz coming pretty soon. So let's just wrap it up, and that's it. Good job, guys. Except for the knowing the double angle, but we're good. That's on me, not on you guys. Bless you, bless you, bless you. Bless you squared.